As we learned previously in the scientific method, experimentation is the stage that takes us from the hypothesis stage to the theory stage. What exactly happens in experimentation? Well, we collect data. And how do we collect that data? We take measurements. So, what kind of measurements do we take? And how do we take measurements? The measurements that we take can get fairly complex. For example, you could be measuring the strength of a magnetic field or the electric field. Or if you have the blood pressure instrument, you could be measuring the blood pressure, the systolic blood pressure or diastolic blood pressure. Or if you have a barometer, as a weatherman, you could be measuring the atmospheric pressure. So there are many different measurements that we take, and for each measurement there is a unique instrument. We are going to look at very basic instruments, and then we will proceed further into fairly more sophisticated ones as we proceed through the course. So whenever we take a measurement, what we get is a number with units. Like it says, a measurement is useless without its units. What are the units? Well, let's talk about a very simple measurement, length. When you take the measurement of length of anything, do you report that as just a number? If I ask you how tall you are, would you say you are 5 feet? Well, sorry, if I ask you how tall you are, would you just say you are 5'6"? No, you would say 5 foot 6 inches. Or you might report your height in centimeters. So the inches, centimeters, feet are the units, and there are a lot of units for any given measurement, including length. For example, just to measure length, you could be using a foot, inches, yard, or miles. And I'm sure there are others as well that I'm not aware of, or um, different countries have their own unique ways of measuring length. But as scientists, we need to have an international way of performing all our measurements so that science can collectively progress on our planet Earth. Instead of using every system, we have decided to use the metric system. If you have ever used the foot, inches, yard, or miles, you have been using the English system. But as scientists, we will use the metric system. Why did we choose the metric system? Because all units are related by the power of 10. If you notice here in the English system, you would see how one unit is related to the other. 1 foot equals 12 inches. And then 12 inches equals 0.33 yard, and 0.33 yard equals 1 over 5,280 miles. Well, they are all very different numbers. The only way you could ever well, there is no other way of keeping track of these numbers except to memorize these numbers. On the other hand, in the metric system, all the units that we'll be using will be related by the power of 10, as you will see. For example, the first unit, apart from length that I just mentioned, the next one is mass. Mass is the quantity of matter in an object. It's not the same thing as weight. Weight is mass times acceleration due to gravity. Now, in the English unit, we use the pound, and the English unit is related to the metric unit of gram. Gram has the lowercase abbreviation g, and 1 pound equals 454 grams. We measure mass on the balance. In the lab, we will see the analytical balance, and whenever we use it, we are measuring the mass. So length, mass, and then there is volume. Volume is measured in liters. 1 liter, or rather 1 quart, which is the English unit that you may be aware of, equals 0.946 liters. Then there is time. Time is measured in seconds. Now, as I was saying earlier, all the metric units are related by the power of 10. And so if we want to express very large uh, amounts of a particular measurement, whether it be distance or mass or time or volume, we can use a prefix from here where I am hovering the mouse. A mega multiplies your standard unit by a million. 10 to the 6 means a million. So if I have here where it says x, if I substitute meter m for x, that means that 1 megameter equals 10 to the 6 or 1 million meter. A kilo multiplies our standard unit by 1000 or 10 to the 3. The abbreviation for kilo is a lowercase k, and so 1 kilometer equals 10 to the 3 meters or 1000 meters. A deca multiplies our standard unit by 10. The symbol for deca is dA, not just d, and it's both lowercase. 1 decameter would be 10 meters. So I used a meter as an example, but we could have as well chosen a second. 1 megasecond equals million second, 1 kilosecond equals 1000 second, or liters, 1 megaliter equals a million liters, and so on. The other 5 prefixes you see here, deci, centi, milli, micro, and nano, are used to express smaller quantities of a measurement. A deci divides our standard unit by 10. So 1 decimeter would equal to 10 to the negative 1 meter. If you know how the exponents work, and please check this out in your scientific calculator, 10 to the negative 1 is 1 over 10. So this is 1/10 of a meter. A centi is 100th, 10 to the negative 2. So 1 centimeter would be 1 over 100 meter, or 10 to the negative 2 meter. A milli is 10 to the negative 3, which is 1,000th. 1 millimeter would be 10 to the negative 3. Now also notice the abbreviation, C for centi, lowercase, M for milli. And then for micro, you have a strange looking symbol. It's not a U. If you were to use your Microsoft Word processor or some other word processor and look for symbols, you'll find this symbol. It's called mu, M-E-W. It's a Greek alphabet. You will find that symbol whenever you need to type a report and say micro. That's what the abbreviation for micro would be, this. And micro stands for 10 to the negative 6, or 1 millionth. It's the opposite of mega. Mega multiplies by million, micro divides by a million. So 1 micrometer would be 10 to the negative 6 meter, 1 millionth of a meter. A nano is 1 billionth, or 10 to the negative 9. 1 nanometer equals 1 over 10 to the 9, or 1 billionth of a meter. So these are the prefixes that we use for measuring different units and going from very large amounts to very small amounts. We don't have such a possibility with the English system. However, we do have that with the metric system, which makes life very easy. When would you use something like nano or micro? For example, you could use nanometers if you want to express the distances or the diameter of a bacterial cell. Similarly, you could be using micrometers for something that's microscopic in size. Millimeters is also very commonly used. You may have seen that also on your rulers. On the other hand, megameters are vast distances that probably astronomers would use. Kilometers take us from one end of a country to the other end, and decameters is used by those who are into farming would be aware of the decameter, as 1 meter equals, 1 decameter is equal to 1 meter. So when they count acres, that's when they generally utilize the deca. All right, then there is volume that we mentioned as one of the units or that we have. Volume measures the amount of space. Now volume is slightly different. It's not just one particular kind of unit, but rather it's one unit multiplied by itself 3 times. So here we are showing what is equal to 1 liter. Liter is the standard unit for measuring volume. Here we say this cube. A cube is basically a shape where all 3 sides are the same length, and this cube equals 1 liter. Each end of the cube is 1 decimeter in length, so from here to here. and whenever we want to take the volume of a cube, we multiply each of the three sides, and we have 1 decimeter times 1 decimeter times 1 decimeter. That gives us 1 decimeter cube, or 1 cubic decimeter. 1 cubic decimeter equals 1 liter. Now here you also see it further divided into smaller cubes. The smaller cube represents 1 centimeter, and if we were to multiply 1 centimeter times 1 centimeter times 1 centimeter, we have 1 centimeter cube. 1 centimeter cube equals 1 milliliter. Please be aware of these relationships, as they are very important going forward.